time that there were like two out of the 500 fastest computers that ran Microsoft instead of Linux. There were some Unix systems still running, but now all 500 of them run Linux.
You're probably the one to ask about the ARM versus Intel AMD competition.
Well, I don't know what type of competition you want to have. I happen to be somebody who believes in RISC architecture. I just believe that the compiler can do a better job of directing the steps that a computer is going to take rather than say, well, we're going to have a whole bunch of subroutines, which we're going to code into microcode. And, you basically are calling those subroutines every time you execute a machine language instruction. So I think that in the long run, in the end, it's going to be a RISC architecture that wins. Right now, I'm looking very hard at the RISC-V architecture, just because it's open, it's a collaborative effort, and
Yeah, I just thought it was interesting that the ARM processor made it into #1 position in the last top 100.
well,
500.
I mean, when you're working with machines like that, the amount of heat that you have and the concentrated heat, that could be something that kills you right there.
Yeah, I saw the power consumption comparisons.
Yeah. It's something which is it's affecting Moore's law too. Is that you can't make all the parts small enough, but getting the power in there to flip the gates and have the gates so close together and flip them at such a high speed and everything generates so much heat and so much electrical power, it just melts the chip right off the substrate. So, it's like somebody said to me one time, you're not an electrical engineer anymore who's designing the circuits, you're a physicist, right? It's the physics of it that's driving you crazy.
Yeah, I started getting into ARM a couple years ago with home television boxes, then got into the development system. So I've been trying to find just the right one to run Linux on. Stumbling around, and they don't seem to be getting the updates as fast as Intel.
Well, I mean, Intel puts a lot of money into the Linux kernel and compilers and stuff like that because, hey, they want it to work well on their systems.
Yeah,
they've got the money to do it.
And I fired up Windows Subsystem Linux with some of the insider stuff. So it's kind of interesting. I'm running a System 76 now, so I feel like it's about as pure as I can get nowadays. Laptop.
Yeah, I haven't heard of System 76 in a long time.
Yeah, Andy Stewart just got one too. Yeah. So that kind of validates my interest.
I remember, Andy was a proponent of that a while back.
Yeah, he got the mini wannabe. So
yeah.
I can't remember what it's called. I've got the Lemur, which is a laptop, and he's got a double high mini system. I think he's still running 1804. He's settled on that with the amateur radio stuff, so he hasn't gone further. And I'm trying out their POP operating system last time I refreshed.
Well, I posted the thing about the Beowulf systems. At the same time, there's been a big announcement that a company named Petrobras has just fired up the largest high-performance computer system in all of Latin America. And what they're using it for is they use sound to be able to figure out what the wells that they drill, the oil wells, look like, where there are holes in the walls and everything like that. And my husband takes the sound waves after they've been processed by the Beowulf system and actually makes the visualization software that shows the engineers what the holes actually look like.
That's
So,
interesting.
yeah. So I sent all that stuff to him. He's still working today, so he didn't have a chance to read it yet, but I think he's going to be happy.
VR headsets are just flat screen.
It's flat screen right now. They're working on the VR headsets.
Yeah. I tried to get into the open source VR and it died and went off another way.
Does somebody have like a radio going on in the background or something?
I've got one, but I don't think it should be picked up. I'm hearing a different radio.
That just stopped it.
Okay, let me turn it off. The clock's chiming too.
Thank you.
Yeah, if you don't have a noise canceling mic, you can pick a lot of stuff up. And I usually recommend to people that they not have their microphone on if they're using their computer speakers.
Nope, these are
Yeah.
teleconferencing headphones from
Mhm.
whoever it is.
Yeah. The Mio.
Jabra.
Yeah. That's what I have is Jabra here.
Yeah. Well, I was using the camera, but I had people in the room talking, so I switched to them. And I haven't
Yeah, I'll
found
turn
the
that off.
threshold. There's usually a push to talk, and I have the settings to know if there's a threshold. It will.
Well, it's 7:00. So does somebody want to get this thing started, or?
Okay, we can. I don't know where Jabber is. He's been quiet. We're recording. So, Mad Dog, if you go up to settings.
Go up to settings.
And
Why?
under more. And if
where is this?
Okay, the three dots on the bottom.
Yeah, okay, I see that. Yeah. Okay, under more.
And then settings, under more. And then everyone follows me. That
Under more.
should, yeah.
So I should everyone starts muted. Is that what you want me to do?
No, everyone follows me.
Me. I see. Okay.
Everyone's already muted, except for Cool Games, you and me.
Okay. All right, then.
Unmuted. I'm not sure what you say. Follow.
We do that for the YouTube, so that Mad Dog gets the priority on the YouTube.
Okay. Well, I did that.
So,
I should be set now.
yeah, you should. It's not all reliable. It would be nice if we could say, you've got the meeting and they automatically focus on you. But it's not reliable.
All right. Well, do you guys want to say anything first? Any, magic minutes for the meeting or anything like that? Or remind people of the barbecue, or you want to do that afterwards?
Jabber, you want to talk about the barbecue?
Guess not.
Okay.
Jerry, do you want to introduce Mad Dog so we have that a brief bit at the beginning of the video, so I can just cut the video right before you start introducing?
Okay. We're running the Boston Linux User Group meeting for June 23rd. This is Alan Turing's birthday, 109th birthday. And he's still around somewhere in our computers. I'd like to introduce John Mad Dog Hall. I think John is a person known to most of us from digital, from Linux General, and from John spoke at our meetings for a long time. And John actually brought Linus to one of our meetings early on, a number of years ago. So, John, go ahead and take over.
Okay. Let's see here. Nope, that's I shouldn't have done that. Close the chat instead of sharing the screen. Here we go. Can you guys see it?
Yes.
I hope you can see. Okay, great. Okay. So my talk today is called No One Buys a Computer. And for the people that don't know me, I've been around in the computer field for about 50 years, over 50 years, and worked at a wide variety of different systems, even IBM mainframes way back when. I first started using Unix in 1980 as a systems administrator for Bell Labs. And then I met Linus Torvalds in May of 1994 and started using free software in Linux. I worked for a wide variety of different companies, and I taught at university for a while, so I've done a bunch of stuff. And as Jerry said, happy birthday, Alan Turing. He doesn't look a day over 108. You know, he's a personal hero of mine, and for a lot of reasons. So I'm going to take you guys back, and for a lot of you, I mean, you've been back there either as far as I have, or sometimes maybe even further. And we all remember that when we started, there was no such thing as computer science. It was more like computer black magic. We didn't know what we were doing, and there was no networking. Well, networking was carrying a box of cards down the hallway to your friend, and security was locking the door of the computer room at night when you went home. And you didn't leave the computer running overnight. There was no way, because you didn't have any guards or anybody to protect it while it's running. And there were no graphics unless you, like Snoopy, pardon me, sitting on top of a doghouse done in ASCII art on a line printer, or maybe that fine-looking young woman sitting on a stool with strategically placed dollar signs. And we didn't have systems administrators. We had, at most, operators who would load the cards into the machine, pardon me, mount the tapes and stuff like that, and then start the systems going. And there was no professional programmers. Professional programmer being somebody who would write software for somebody else. That was their profession. That's what they did. Most of the people wrote programs to solve their own needs. So if you're a mathematician, you use a computer to solve mathematical problems. So if you're a physicist, you would use a computer to solve physics problems, and so forth and so on. And like I said, most of the systems didn't even have an operating system. Now, people, you, me, normal people, never bought computers. They were simply too expensive. Many times the computers were rented from the company that built them, or maybe a couple different companies or a couple different universities got together to buy the computer and share it between themselves. There was certainly no computers in homes or high schools. Not even Wozniak had them back in those days. And the only time that most people saw a computer was on the TV in a university, and what they really saw was a spinning tape drive. That was the computer to them. And software was owned by the customer. You wrote it, you owned it. And if you did buy software from somebody else, it was protected by contract law, because you couldn't copyright software back in those days. You couldn't apply a software patent back in those days. And so you sat down and you negotiated for months sometimes to buy a single copy of a compiler. I remember at Aetna Life and Casualty, we spent over $100,000 US for a single copy of a compiler for IBM mainframe. And that was when $100,000 was a lot of money. And we sat down with the lawyers and the product managers of the company we're buying it from and made this long contract that said how many computer systems could you put it on and how many people could use it and when you were going to get updates and what happened if you had too many bugs and stuff like that. And that was the way we bought software, if we bought it. But a lot of times we wrote it ourselves. Now, over time, the hardware cost dropped and kept dropping, as we all know. The margins were reduced on each piece, but the volumes went up because more people could afford them. And eventually, as we all know, PC stores opened up and grew and then dropped out of sight because, again, the margins kept going down and down and down, and it makes harder and harder for people to make a living that way. Just like Blockbusters. Right? Blockbusters came and went. And hardware that used to be an asset and would receive an asset tag and be depreciated year after year, that disappeared too. I remember that there were people who bought VAX 11.780s, had an asset tag put on them because they were $250,000 and you were supposed to depreciate them over 5 years. Well, the machine didn't last 5 years. It was worthless after 4 years, but you couldn't get rid of the unit because it had that stupid asset tag on it. So you just moved it out of the hallway, unplugged it, and you kept it there until it was fully depreciated. And then because the software was now produced by a company or an individual, it became closed and protected through obscurity. You know, when you bought it, you didn't buy the software. You were buying the right to use the software. And then at that point, there was other people who were deciding what you needed in your software, and they would provide it for you. And you guys all know that it's really hard to produce 100% of what anybody needs. And it's also hard to reach 100% of the market. So most people, when they're producing software, they're lucky to produce maybe 60% of what the customer needs, or maybe 80% of what the customer needs, and it's 80% of the customers. And if you do matrix mathematician there, math, 80 times 80, it means you're actually only meeting 64% of what the market is looking for, and that's a problem. So the larger companies sold systems. They sold the hardware, the software, and the support. They had software specialists who would go out to the customers and help the customers use the software. They developed channels of distributors and stuff like that who then sold to retailers and the retailers sold to the end users. And so the end users, in order to try and get something fixed, had to go through the retailer, the distributor, or maybe all the way back to the OEM. So these large companies started to create stacks. Companies like Oracle and SAP and PeopleSoft, they would create these large stacks of programs that would try and do everything for everybody, but they were really expensive and they used up a lot of resources and they were hard to tailor. And I'm sure all of you guys have been there. Now, in the year 2000, IBM, you've heard of them, right? They decided that there's this Linux thing, and it's kind of interesting. And they were going to investigate. They were going to invest $1 billion into Linux. They were going to hire Linux developers. They were going to try and make Linux work really good on their systems and everything. And later on, the next year, they reported back and they said, you never had that $1 billion that we invested in Linux? Well, we made $2 billion off of that. So that was a good investment. and everybody was kind of shocked. And IBM, just to show that this wasn't a thing, the next year they invested another $1 billion. Now, another interesting thing about IBM is that in 2005, they sold off their desktop and laptop business to Lenovo. And people say, wow, what did they do that for? That's crazy talk. You know, I mean, that's a lot of computing power, and putting that into Lenovo's hands. But a lot of people didn't realize that the money that IBM took and got from Lenovo for that business, they immediately used that to buy PricewaterhouseCoopers. That was a support and integration company, and IBM doubled their integration and support business by buying PricewaterhouseCoopers. Now, if you took a look at desktops and laptop business at that time, particularly Intel systems, you found out that the final profit ratio on them was about 2 to 3% back to the OEM. That's all the OEM could get out of that business at that time. It's not to say that the retail people didn't get that, but that's what the OEM was getting. And IBM could not survive off of that type of return, that type of profit. However, in the computing consulting business that IBM was in, there was a 19 to 20% ratio of profit. And so all the good managers that they had for their desktop and laptop business, they kept the good managers, and they said, we're going to invest all this money we got for this business in consulting and business. And then later on, they sold to Lenovo the Intel server business, a small end business. They still kept their mainframe business because that also was high profit margin, but they sold everything else off. And it was in 2005, I was at a Linux show in New York City, and IBM was having a contest. And the people that won the contest actually won 2 Apple laptop computers. If it had been a day before that, and the IBM people had given away as a prize an Apple laptop computer, those people would have been fired. But what IBM realized at that point was, by selling off their desktop and laptop business, they could now give to their customers anything the customer wanted in the way of solving their business problem. And everything was cool because, you know, Apple was just another laptop and desktop maker. And if the customer wanted Apple, well, then the customer would get Apple. So this was a pretty interesting thing for IBM. And if you guys think back, you'll realize that when you go to the airport today, you never see IBM mention a piece of hardware or a piece of software. They don't mention their operating systems. They don't mention their hardware. All they mention is business solutions. That's what they sell. In 2014, they invested another $1 billion, and then a little bit later, they bought Red Hat. And there was a lot of angst in the community that IBM was going to destroy Red Hat and so forth and so forth. But then later on, Jim Whittaker, who had been the CEO of Red Hat, was then made the president of IBM. So this is an interesting stuff. It's kind of interesting, but IBM is still talking about selling solutions. I also was lucky enough to go to Austin, Texas a number of years ago, and I saw the Casio Linux watch that IBM had worked on with Casio. Unfortunately, it never made it to to product, never made it to market. But it was an interesting research thing that IBM did. So if people don't buy hardware and software, what do they buy? Well, they buy solutions to problems. And, even playing a computer game is a problem. You want to play the game, well, maybe a computer is a good way of playing it. And, you might be able to play the same game using 2 tin cans with a string between them, but that's what you're trying to do. Maybe you want a networked game. But it just so happens that these wonderful things like computers can do all these wonderful things and do them in a very flexible way. It's the same way that the Model T Ford had a solid connection between the brake and all 4 wheels. You pressed down on that brake and you had the pressure go out to all 4 wheels, but it was hardly ever equally applied. You had to keep constantly tweaking the braking system so that the brakes were applied in a proper way. Along came hydraulic brakes, where you press down the brake and now it was the fluid which was going out to all 4 wheels and applying it to stop you. But today, if you press on that brake, it's just a little potentiometer of some type that measures how hard you're pressing, and then it goes to a microprocessor that sits there and says, okay, I'm going to be applying the brakes in the best possible way to make sure that the tire isn't skidding across the road. The tire stays in contact with the road, because that is the fastest that you're going to stop. If your tire starts to skid and is just skidding across the surface, then you're not going to stop as fast. And, we don't have mechanical windows anymore. At least a lot of the time we don't have mechanical windows. We have electric windows. The whole car is being turned into an IoT system. And so the game has changed. And when you look at it, you step back, and you look at it from 20,000 feet, you realize that computers don't cost millions of dollars anymore. You have an SBC that's a really powerful little computer, and you can even do web-based development. You don't have to have a development system. You can do your development across the web with web-based tools. A lot of people are now realizing the software can be collaborative. You don't need to own everything in the solution. You can own just a portion of the solution, and that could be the thing you sell, and the rest of the software. I think all of us remember where when we were writing software, we wrote to file systems and we wrote to files and stuff like that. And then along came this thing called a database. First, they were relational databases, and then first they were hierarchical databases, and then they were relational databases, and then they were object-oriented databases. And these days, if you start off with a project, you probably should just say, well, which database am I going to use? Because there's lots of great databases out there that are completely free of charge. And, all these things that we had to write from scratch are now available in massive amounts of software that we can use. If you go to market your product, the marketing is social these days. You don't really need to go to a huge marketing firm and spend thousands of dollars to get going, when you can maybe start off just selling your stuff on Facebook, or selling your stuff on some of these other marketing events, or maybe doing some crowdsourcing and crowdfunding of your solution for your customers. And part of that is having a nice prototype that you can show people. A lot of times you go to some of these crowdsourcing things and they say, oh yeah, we're going to do this wonderful thing and it's going to take us 2 years, and we want your money up front. But you don't have anything to show them at all. But on the other hand, if you can show them a working prototype and say, yeah, we just want to, tighten it up a little bit, make it a little bit better and stuff like that, you'll have people who are a lot more likely to fork the money over for that. Another thing which is going on is that, the companies could be smaller because you don't need to do all this stuff, or you could outsource a lot of the stuff to an agency instead of having to hire the people to do it for you. And so you can come up with a single owner business, or what I prefer is an employee owned business where everybody is contributing and everybody is the owners and everybody gets the rewards. So that's a little bit about how things have changed and how it can move people to actually creating solutions for customers instead of just selling them products. And I'm going to come in now and talk about some solutions for customers that I think have a great market potential. And the first thing is a point of sale and an enterprise resource planning system. Now, all of you guys have been to McDonald's and to small supermarkets and stuff, and you see the cash register there that's no longer the brass thing with the big buttons that you press down and the numbers fly up and the drawer falls open. Instead, it's an LCD panel and a scanner and maybe a scale that sits there. And this is the point of sale terminal, and you have the parts that you can touch on the LCD panel to say I'm buying onions or I'm buying peppers or something like that. So that's the point of sale terminal. But then behind that is typically an enterprise resource planning system that allows you to do things like inventory and accounting and customer relationship management and things, and automatic ordering. If things get down to a certain amount, you want to put in the order so you can get it right, keep your inventory up. All this type of stuff is in enterprise resource planning. And there's a couple ones that are around that are pretty famous. NEC is a closed source model. And there's one called Micros that was recently bought by, a couple years ago, bought by Oracle. And both of them are not very extendable, certainly by the end user, and they're fairly expensive. And if it's Oracle, it's fairly expensive and fairly expensive and really expensive. They charge $5,000 for the first software license with no hardware that goes along with it. That's just a license to get going. And it kind of goes up from there. Now, on the other hand, there's a software called Odoo. And Odoo is kind of like an open source backplane where you have a whole bunch of modules that you can plug in there. Your inventory module, your CRM module, or you may have a couple different modules to go in there to do much the same thing. One of them may be completely open source and completely free, and the other one might be one that is either charged and open source or is closed source, and they have, you can plug them in. There's a community association that goes along with this, that a bunch of people who work together to create more modules and more functionality of these systems. And as they upgrade the backplane to port the modules from the old version of the backplane onto the new one, there's also some support companies, 1,568 worldwide, 81 as an example, 81 different companies in the USA that sell and support these type of systems for customers that want to buy them. There's 13 in Brazil. And they normally work over the internet. They do have some salespeople that will go out. And they also have people who will do installation for you if you can't do it yourself. So the last time I looked, the worldwide organization was installing about 1,000 ERP systems every day. So it's a big thing. They have meetings and all sorts of stuff, a pretty wide thing on the net. Now, we can take a look at the hardware and software in specific. The source code is available for the backplane and available for the modules, most of them anyway. And this all can work on Windows if you want to do that, but of course it also could work on GNU Linux. And they have a Deb version for Ubuntu and Debian, and they have an RPM version for Red Hat, or you can pull down the source code and compile it yourself. It works on Intel and AMD and ARM 64-bit as an example. So here's a little example of the of a point of sale system, but basically this is the point of sale system. Unfortunately, it's kind of a small picture. Maybe I have a larger one later on, but it's just a little single board computer. Now, I'm working down in Brazil with a project called Caninos Lucas, and we are creating a single board computer called the Labrador. It's actually made up of two boards. One is a core board. It has the CPU, the memory, the GPU, and all the active components on it. That slides down into an I/O board, which has all the connectors and stuff like that. And the reason we do that is because you can have the same I/O board for either a 32-bit or a 64-bit version of the core board. And later on, if you build a core board into a product and you say, well, I want a faster CPU or I want more RAM or something like that, you can slide out the core board and stick another later version of it in and not have to disturb your I/O board. So we think that that's pretty cool. But in any case, you then use a USB printer, which has off of that a cash drawer that would open up when you say, okay, print the receipt and take the cash. Opens up the cash drawer that runs off the printer. You can use a handheld USB scanner, and there's a whole variety of them that work very well with that. A USB scale to weigh your bananas or your peppers or whatever you want to weigh. You stick an LCD panel on that, a keyboard and a mouse, and boom, you have a point-of-sale terminal, and it costs about $700, quantity one. Now, if you're buying these in any type of quantity, if you're making a business out of this, of course, you would get quantity discounts. You would go back to the distributor instead of to the retailer for buying this, but quantity one, all these items, you could buy it for $700. On the back end, I should also say that this code also works on a Raspberry Pi. So Raspberry Pi would actually reduce that quite a bit, by about $50. Now, the ERP system is also can run off of a Labrador or an RPi. Get a Visa mount to put it on the back of your LCD panel. You want a hard disk on that to be able to store enough data, and then everything else is the normal type of stuff, and the software, of course, for all of this is free. So now you can think about having a small supermarket where you have one point-of-sale terminal for each one of your sales, your aisleways. The people are going to come down and start to ring up their stuff. And then an ERP system as a back end for each store. So here's a picture of a guy. He's from a company called Cami in Brazil, and he was helping me put together this demonstration at a conference. And what we were trying to do was get high school students and university students interested in learning Odoo, in selling these type of systems, and use this to raise money so they could go to university. Universities in Latin America, if they're state or federal universities, are typically free of tuition. If you're a qualified student, if you get good grades in high school, if you get into the university, there's no tuition. Unfortunately, about 40% of the students who do that or who are qualified to go to the university still have to turn it down because their family is too poor to buy the apartment in the city, to pay for the food, the transportation, the internet, the computers, the books, and everything else. And typically the oldest child in the family maybe has been working since the age of 15 to help to get the family money to pay for all their siblings. And so they can't afford to go. Maybe the younger kids can later on. So what I want to do is show these kids how they could actually sell these systems and support them. And if they had 6 customers, 6 stores that needed a point of sale and ERP system, they could charge each one of those stores for 1/6 of what a systems administrator would be. And they'd work 4 hours each week in every one of the stores. That's 24 hours a week. And they would get a nice sum of money for Latin America. They would be able to afford the apartment and the books and the computers and the food, and maybe even have enough money to send back to the family. So we call this Project Cal One, and this is one of the things that Project Cal One people would be selling. There are a couple books available on Odoo. They're both written by the same guy. One is a little bit lower level of, actually how to install it and all that type of stuff. The other one is more of a overview of what an ERP system is and how to set up inventory and stuff like that. So it's worth buying both of them. And of course, you can go to the Odoo site and they have all sorts of videos and information on Odoo and stuff like that. Now, Odoo isn't the only open source ERP system out there. There are others. But it's kind of interesting that the Linux Professional Institute, of which I'm the board chair, independently did a study of all of the ERP systems, and independently of what I was doing, chose Odoo as the ERP system for LPI. So we run the Linux Professional Institute off of this ERP system. We do our sales of our certification vouchers. We keep track of our certificates we offer. We keep track of our membership program and so forth and so on. All of that through Odoo. So that was Odoo. And then another kind of interesting solution is FreedomBox. And FreedomBox is a free software server for your home, although you could actually run a small business off of this server, or maybe a small community of people off of this server if you want to. But the main thrust of it is there's no binary blobs in the whole thing. If you buy a FreedomBox hardware from them, which is basically a little SBC system, they specifically have worked to make that SBC system have no binary blobs, nothing in the BIOS, nothing in the graphics. You can see everything. And they've also made it easy to set up and maintain this system. I wouldn't say that my mother and father would be able to do it, but you also don't have to be Paul Vixie, the writer of Bind, to set it up either. And it's a graphical way of setting up, and every day they get more and more documentation to help people understand what they're doing and to set it up. You can make this out of a single board computer, and they have on their website a whole bunch of them that work perfectly fine with this, and use 2.5-inch hard drive or SSD. The reason I keep saying the 2.5-inch drive instead of a 3.5-inch drive is that with a 2.5-inch drive, you can get a cable about $8 that goes from USB 3 to SATA. And you can drive that little disk at laptop speeds, laptop transfer speeds or SSD, and it takes the power from the USB 3. So you don't have to have a separate power supply for the hard drive. And all of this code is included in Debian 10. So you download Debian 10, put it on your either ARM or Intel system, and you too can have a Freedom Box. Now, all of this was started by Eben Moglen. I don't know if you guys remember Eben, but he's the guy who wrote the GPL version 3. He's a law professor at Columbia University, and he believes in free software. He believes in security. He believes in privacy. And he was just all upset by the whole Facebook, Google, sell your data thing. And he wanted a way to people could have a really secure server and maybe just plug it into an outlet in their house. So he started this, and people like Badale Garby from Debian got into it. A whole bunch of people got in to help him. This has been 10 years in the creation. And about 2 or 3 years ago, they brought out their first version. So you can go to freedombox.org and see what all the stuff they've done. Here's a listing of all the different programs and functionalities that they put into this to have this. And what's happening now is that other people with other federated social media can be putting this on top of the Freedom Box. So Diaspora, where you could have, a social network of people that you know who they are, and you store your data, and you say what data you're going to make available to them, and so forth and so on, is one of these things. GNU Social is another one. Mastodon is another one. So you could put this on top of the Freedom Box, and because it's Debian, you could also, make a NAS server out of your little Freedom Box and run your entire network inside your house on it. So it's really powerful software. There's a big community behind this, and it's worth looking at. The third one I'd like to, I'm sure you've all seen Kodi and everything like that, and you're familiar with it. If companies are making smart TVs, they probably are using Kodi inside of it. And you can show videos and TV shows over the network and stuff. You can play your music through it. You can show your photos with it. You have a VCR from it, and games and lots of plug-in add-ons add new functionality. But there's more. I remember, and you do too, when you had a stereo system, you bought a turntable, and then you bought a equalizer, and then you bought a tuner, and then you bought a mixer, and then you bought a power amplifier, and then you bought your speakers, and all of those kind of plugged in together because they're all analog and everybody was singing Kumbaya, and you could build a really nice stereo system. And when you got a little bit more money, you would unplug one of them and plug in a better one, and so forth and so on. But then all of a sudden things got really weird, and you found out that your Sony speakers somehow only worked with your Sony receiver, and everything became built back into one thing. And that became a little bit worrisome to me. So with this, what you can do is buy a power amplifier, and your computer becomes all the other stuff. It picks up the signal, it does the mixing all digitally, and it feeds it to your power amplifier digitally. And your power amplifier actually has no buttons on it. No buttons, no dials, no nothing. A little blue light, that's all it has. And on the back, it has plugins for all your speakers. And when you turn it on, when you put the power on it, within half a second, it kind of shuts itself down and it draws maybe 1/3 of a watt of power while it's sitting there waiting for something to come through its digital interface. And when that something comes through the digital interface, then it turns on in half a second and it starts playing the music. And after all the zeros and ones stop for like 10 minutes, it goes back into its quiescent state again, and it's only drawing like a third of a watt again. So basically, your power amplifier never turns off. It's always sitting there listening, just like your TV never turns off, and a whole bunch of stuff never turn off. But everything is done digitally. It's all digitally mixed, and it's coming out through either your HDMI or through your digital output on your little SBC computer. So, and you can go all the way from stereo, just 2 speakers, to 2.1, which is 2 speakers and a subwoofer, to 5.1, which is, you're familiar with that, and 7.1, you're familiar with that. You can keep building your power amplifier up. You could NFS mount your phone with all of its video and all of its music sitting on it. You can NFS mount your phone to the system and play it back through your Kodi system onto your large LCD panel. Or maybe what you have is a LCD projector to project this onto your wall or onto a screen. This whole system can be your first connection to the internet. Now, we don't think too much about this because we live in a country like the United States, and we don't have very poor people that don't have a really good connection to the internet like they do in Brazil, where 30% of the households have no connection to the internet. They would love to have one, but it's very expensive. They have to buy a computer. They have to buy, the internet connection. And the internet connection has a modem and it has a Wi-Fi router. Well, if you have this little Labrador or Raspberry Pi, you don't need the Wi-Fi router anymore. You plug the modem into the back, into the hardwired connection to the internet, and then you use the Wi-Fi chip on the board to act as your Wi-Fi router. So that helps cut down the price a little bit. But the other thing is that this system you have now is not only your multimedia system, it not only gives you music and video and pictures and all this type of stuff, but you can actually use it to access the internet and to get services from your government that you couldn't already get. You can use it to learn. And you can also use it to control your house. You can use it to turn your refrigerator on and off at the right time, turn your air conditioning on and off at the right time. In fact, if you have a power company that's environmentally interested, they want you to use this type of system to control your house because they can now control when you turn on your air conditioner or not. And they can help to cut down on the peaks of power that are used. If they can level out those peaks of power, that means that they don't have to start up their coal-fired plants, or as many of them, or their oil-fired plants or their natural gas-fired plants. They don't have to start them up because they're managing their electricity better. And so Itaipu, world's largest hydroelectric plant, is very interested in this concept. And Itaipu might actually buy the little single-board computer for these houses, and the government might even supply them with internet so that the government can help them more. And of course, all of this is Debian-based. Now, a lot of things that people don't discuss a lot is the fact that over-the-air TV still exists, particularly in large cities. Sometimes there's 2, 3, or 4 channels that you don't need cable at all. So you can get all these TV shows and informations and stuff by using this little module that goes into USB. And not only that, but there's an extra channel in that space that's open for data downloads. It's kind of a complex subject, but we can get onto that later. If you take now a lot of these houses in Brazil and in Latin America and other countries, they have bars over their windows to keep people from breaking in. And it's an unfortunate type of thing. You know, not many of us have bars on our windows, but down in Brazil, in Argentina, they do. So really, the only way that somebody's going to get into their house is going to be through the front door, or into their apartment, through the front door. There is no other way in. So if you put a little webcam on this, and because this computer is never turned off, you put a little webcam on there, you aim it at the front door. When you leave, you arm it, and you say, if anybody comes into that front door, take a picture of them and send it to me. We'll put it into the cloud. And so it can be a simple burglar alarm system for you. And finally, the price of LCD projectors is dropping dramatically. You can get a pretty nice LCD projector for a couple $100 instead of having to buy a very large screen TV. And a friend of mine named Douglas Conrad runs a company called Opens down in Brazil, put together one of these systems, did everything I've talked about here, put it all together, had it working, used his Android phone or his iOS phone as a remote for Cody to control it. And he would invite people over to his house during this. He put the whole stereo system together. He had 7.1 stereo, everything. He'd invite people over his house and they'd be watching TV and they'd be, do you want to listen to music? Oh, yeah. You put on his music. You didn't have to get up from his chair. He'd just do something on his phone and boom, the music was going through the house. And after a while, the people say, hey, where'd you buy this system from? He goes, oh, well, I didn't buy it really. I'm putting it together. This is more of a project instead of a product. And his friends would say, no, you don't understand us. Where did you buy it? How much do I have to pay you for it? Because I want one. So, this is another project which could be put together, a list of components. These all have been tested and work together. Buy these components, and you can go out and sell these to people and, update it over the web. Now, I know all of us have been in free software a long time. And I think most of us can remember when you went to places like SourceForge, and there might be like 50 different projects out there or pieces of software and stuff. And there might be 13,000 people working on it. Well, now you have to do a little bit more. You have to go to GitHub and GitLab and SourceForge and a bunch of other places and scour around a little bit. But now you find out that there's 400,000 projects out there, and there's 26 million people working on them. And they're either open source or free software. And there's dozens of cheap SBCs, with each one having different capabilities. Some of them have PCIe, some of them have USB 3, and some only have USB 2. Some of them have 2 gigabytes of RAM and 4 gigabytes of RAM, and some, like the Raspberry Pi, have 8 gigabytes of RAM, and just a wide range of stuff you could put it on. And so you could put together dozens of solutions for people and make a business out of it. And maybe it's something you do on the side, and maybe you get high school and university students to say, hey, would you like to sell these? Would you like to be the frontline person in sales and support for this? And you can get a certain amount of money, and I will take a certain amount of money for, doing the upper level work. So that's what we're doing with Project Kalwan. And I'm working with a pilot right now in a little city called Ubatuba. Isn't that a great name? Ubatuba. It's a little seaside thing that about 2 weeks out of the year, it's very crowded. There's lots of people there. It's the summertime and there's lots of money and everybody's happy. And then for the other 50 weeks a year, it's like a ghost town. But during the pandemic, they had a lot of people because it's kind of equidistant between Sao Paulo, the largest city in the Western Hemisphere, and Rio de Janeiro. So people came from both these places to say, hey, we can't work in the office anymore. We're going to work in Ubatuba and call into the office. But they want to have training and they want to have support and stuff like that. So we're working on a program to create that for them. And I'm picking up some noise here. It's kind of annoying. Thank you. So this is basically what we're doing. And with that, I see some stuff in the chat. We can talk about that. If you guys have any questions, I've been babbling on for a long time now. You could, ask questions or comments. Do I have to do something to let other people talk or anything?
No, anybody can talk if they want.
Okay.
So all they have to do is just turn on the mic. And so you're showing up as an avatar.
I see a thing down here. Jerry, you said you can talk about the 1974 BKPOS system?
Yeah, Burger King had a point of sale system back in the very early 70s.
Mhm.
It was written in assembler language for the PDP-8.
Mhm.
And it essentially only was a 4K PDP-8 because it didn't want to spend the exorbitant amount of money to make it 8K. I believe the extra board for that cost $5,000 at a time. But you multiply that by the number of stores.
That was probably core memory, right?
Yep, it was core memory. Connecticut had 8K because of their tax routines. Connecticut, we had to write sales tax and meals tax for Connecticut. But every other state was just meals tax or sales tax, not the two in the same place. But
well, with Canitas Lucas, I can tell you one of the biggest problems that we had was in the tax situation. A Raspberry Pi coming into Brazil, a $35 Raspberry Pi would end up as $150 street price in Sao Paulo. And the reason for that is $35 Raspberry Pi, $20 of shipping, $5 of insurance brought it up to $60. The customs duty doubled that to $120. And then if you want to make a little profit off of it, it ended up being $150.
yeah, exactly.
So Canitas Lucas started off with the concept of buying packages of parts, bring them in, and then just assembling them inside of Brazil. And when you brought in the packaged parts, the components, there was only a 16% tax on the components, and that tax was only if they were things that were not made in Brazil. So if they were made in Brazil, then they had a 16% component tax. If they were not made in Brazil, like an SoC, that could come in for free. But one of the big savings was in the printed circuit boards by having the printed circuit board made in Brazil, because they were both heavy and a good part of the cost, and we made out like bandits by using locally made printed circuit boards. Okay, which Linux platform do you prefer? You mean which Linux distribution? I keep being asked that, and I keep refusing to tell people. And the reason is that I am a consultant, and therefore I use the platform that my customers use. So for me to tell you I use Red Hat or I use Ubuntu or I use Debian is just ridiculous because it has no meaning. I just go back and forth between them. It doesn't. Now, with these products I've been talking about, you may have noticed I've been stressing Debian, and mostly that's because we've been, creating the changes to the kernel we need for the boards and stuff like that, been feeding that, making sure it gets into Debian distribution. And Debian tends to have all of the packages that we need. So they ship the Kodi stuff, they ship the Udo stuff on there, they ship Freedom Box code. They tend to pull all this stuff in, so it's a good one. But I mean, Udo also works, as I said before, also works on Red Hat, also works on SUSE and stuff like that. I like the reference to IBM in the early interesting for Linux. Oh, yeah. I mean, I was, when I started, I was active with Linux International and stuff like that. I got to know Dan Fry, who is like one of the senior managers handling IBM's open source stuff. And I was good friends with him. He took me to this meeting in Austin, Texas one time of some of the developers for Linux and IBM. And he asked me to give a talk, which I did. And he says, okay, now you have to stand backstage because we're having a regular business meeting and that's closed to anybody except IBM personnel. So just stay here in this little green room and we'll come and get you when it's time to go out. Okay. Well, about halfway through, I had to go to the bathroom. So I started to get out of the green room and looking around for the bathroom. And I happened to look up on the big screen was this letter from Lou Gerstner being projected up on the screen. And on that letter, it said, in the past, IBM has been a closed source company unless there's been a business case for us making something open source. From now on, we're going to be an open source company unless there was a business case for us being closed. And I looked at this, and this was like the most powerful letter I'd ever seen. Because at Digital, we would have products that we were going to retire. Maybe it's a graphics library or something like that, or maybe it's an old database we didn't want to support anymore. And the engineers would beg the company to just open up the source code. Just let the customers have the source code so they could maintain it. And our lawyers and our product managers would drag the engineers through the equivalent of a gauntlet. And after even if the engineer was successful in coming out of that, they'd say, never again. I'm never going to advocate for a closed source product being open source. And what Gerstner's letter did was it turned that around and made it all back on the managers. And say, if you can't tell us why we should make this closed source, well then, why not make it open source? It's already there. It's, we're just going to make it an open source project. And it's just, I knew that was going to just turn things around inside of that company. Question for John. I may have misheard, but did you mention something about a data channel related to over-the-air TV? Yeah. Okay. I mean, you have these frequencies that are divided into channels. And this little controller, this USB controller, it works with different countries. So in Brazil, I think the standard is SBT. I think that's the name of the standard. It's done in Brazil. It's done in Japan. Actually, it's done through Latin America and Japan and a couple things. We use a different one. I think I can't remember all the letters and stuff. But you have all these different channels. Now, if the channel isn't being used by a broadcast, system through like a TV station, the channel is available for other things. And you could download data from a TV tower or something like that into the computer from that channel. And that's a lot of data. That's a big, hairy, hunking, massive data that's available to you coming down there. So the government could come along and say, well, we're going to use, these top 5 or 6 or 7 or 10 channels to download data from the government's website into the computer if we want to do that. And I think Professor Zufo of the University of Sao Paulo told me it was something like, a couple hundred megabytes a second that they could do in Brazil. So that's another advantage of that. And there's 3 major standards for over-the-air TV. I'm sorry I can't remember all of them, but I could find out and I could let you know. And there's a company that makes these little USB plugs that are, I don't know, $20, $30 a piece. Any other questions? Access security for these home IoT systems being designed with between arms. This is a big problem particularly for the for Itaipu. So, like I said, Itaipu is the world's largest hydroelectric plant. They produce 25% of the electricity for Brazil and 90% of the electricity for Paraguay. And so that's a lot of electricity, a lot of money. And they're terrified of people getting into the electric grid through some type of IoT system. So what we're looking for is the ability to inspect every single packet coming in and out of the system, to apply some fuzzy logic to it, to make sure that there's no known virus or thing like that coming in. So it has to be set up very, very carefully. And one of the things we're looking at is having every single part of this, the IoT part, the Kodi part, the TV part, so forth and so on, be in a separate container or even a virtual machine to be separate from everything else. And then to maintain the integrity between those. So that's still a little ways away, but we are looking at that. And, all of these things, we're in the process right now of actually prototyping them, finding out how much people want to pay for these stuff, because we can't just give them away. But we are working on some interesting financing, because the Social Security system in Brazil, for example, there's 60 million people on some type of Social Security in Brazil. Maybe they're fully retired, maybe they've been hurt in some type of thing, or whatever. And the Social Security agency or ministry has to manage all of that. And this is going to seem strange, but right now, if you're on Social Security in Brazil, what happens is you have to go to a place like a store or storefront or something. There's a machine there, and you take your money that you get from the government and you pay your bills while you're staying there in line in front of this machine, because you don't have internet in your house. And so this is how, the government gives you money. This is how you pay your bills through this system. And I said to this guy, well, what would happen if we had a secure way of actually allowing people to have this software in their house that they could sit there and do this stuff in their house? And the guy says, oh my God, that would be great. That would be wonderful, because he was sympathetic to this. He didn't like the fact that these people had to stand there and do this crap every month. On the other hand, you also have the thing that they have the lottery system. Well, why can't people buy lottery tickets, through their computer system in their house? In the United States, it costs about $350 a year to supply textbooks to high school kids. And you remember, you guys remember, every year you got your textbooks and you used them, and sometimes they were ripped up and sometimes they had little markings on them and stuff. And then every year you took them back and then people looked at them to make sure you didn't rip them up or mark them and stuff. And then they put them away again. And after a couple of years, your science books were like 20,000 years out of date. Well, if you have the internet, you can cut down on all of that. You can use Project Gutenberg to get all of your English literature books. You don't need to buy a copy of Charles Dickens or Mark Twain or whatever. And that's a lot of money saved. I had a great deal of frustration this past year because of COVID and all these teachers and stuff who say, well, we now have to teach over the internet. We don't know how to do that. And my niece has been teaching over the internet for the past 15 years. She works for a company that is a public school. They sell their services to 10 different states. And from kindergarten all the way through 12th grade, the kids are only taught from their house. The company buys them the internet connection. The company buys them a laptop. And the school is free to the students. It's because it's a public school. It's paid for by the taxes. My niece all the students can see my niece. They can hear my niece. But they chat back to her. She can't hear them. And she's been doing this for 15 years, and they've had kids go all the way from kindergarten to 12th grade, graduate, go to university, and they've kept track of them. And these kids do just as well as the kids who've gone to the brick and mortar schools. They set up things like physical education in Boys and Girls Clubs and YMCAs and stuff like that, so the kids get their physical education. They get to mix with other kids in those areas. And I kept telling her, when the pandemic started up, I says, you have to tell the rest of the world what you're doing because they're clueless. And for some reason, they just didn't do that. So, it's even if you don't do that completely, what would happen if you said, okay, half the courses you go in the morning, you take half your courses, you go home, you take the other half, and then the other half, the student population, goes to school in the afternoon, takes their courses, and in the morning, they do it over the internet. So now you've doubled the capacity of your school. And this is the type of stuff that, we really need to think about. But, without the internet being there, I'm just very frustrated with our government not recognizing that if we're going to be repairing the roads, if we're going to be working on the grid and making it stronger, why not install internet at the same time? Why can't we do the same thing we did with the rural electrification program many years ago? Why can't we do the same thing with rural free home delivery that we did even before that?
I just heard something on the news the other day about some municipality broadband being basically banned. Yeah, it's interesting.
I have a place, Mason, New Hampshire, relatively close to my house. They didn't have any cable TV or anything like that. They had to do with satellite TV and satellite internet. And it was very, very crappy. So they took some of their CARES money and they created a community internet group and brought fiber to every house. So they went from like 2 megabits a second up to a gigabit a second because they did the
Nice.
planning. The system belongs to the town now. It doesn't belong to Comcast or anything else. It belongs to the town, and they've got really good internet now. There are groups that help encourage people to put together community internet. In fact, the Internet Society, which is a friend of mine, Dan York, is the president of. You go to their site and they have examples of people putting together community internet. So somebody down here, open education resources. Yeah. There's lots of resources out there, but you have to have the internet to get to them, right? And the people have to have the equipment to get there. But I think a modern day Raspberry Pi would be plenty fast enough to help somebody do that. I'm going to copy do a cut and paste on your education resources there. Oop. Any other questions or comments or anything like that? Because we can open it back up to more of a general discussion. Okay, I'll mail my slides. Should I mail it to you, Jabber, or you, Jerry, or who?
Jabber would be best.
Okay. I'll do that after the meeting.
Okay, that'd be good.
If anybody wants, I can talk about the Burger King point of sale system, since how primitive it was, but how effective it was.
Go ahead. It sounds interesting.
Sure.
Okay. Well, it was the early 1970s. I went to work at thanks, Mad Dog. I went to work at Burger King in 74. And the project that I was assigned to was the point of sale system. It was as implemented in the restaurants, it was a 4K PDP-8M system. It had no peripherals except for a modem. To load the code, you actually had to take the front panel off, put in a board for punch paper tape. Or we were actually working on a program to download the code to it. It had a keyboard, like you press key for a Whopper or a Coca-Cola or something like that. It was not an ASCII keyboard. You actually had to read the rows in the column to figure out what key it was. The modem would send a bit or receive a bit at a time. You position a bit into the link, which was the only register in the PDP-8. Well, it was the accumulator, and the link was like an overflow bit. So you'd rotate a bit into the link bit, and you'd tell the modem to send or receive into that bit. Very, very primitive. The printer was a drum printer, and you'd have to time the each row on the drum. You had 10 rows in the drum, so you could do 0 through 9, but you couldn't do a full alphabet. So that's why a Whopper was a WPR and not WHOPPER on the printer. And again, so you had to map out, figure out what these words were that you're going to say. And essentially there was a blank line and then 9 other lines. So it was, one of the things you would just wait for the next row to come around. It would interrupt you, and you'd have to print what letter, what character you're going to print set up in the accumulator register. Very, very primitive system. And I said, if you, no paper, no on tapes, the modem, once every night we would send the data down to Miami or sit there. But we did have accounting things. We did have, for instance, a cash reconciliation. And our rules were cash reconciliation could not be done at night. Had to be done in the morning because of robbery control. But they kept inventory and stuff like that. But they only had a day's worth of data, so they had to transmit all the data down to Miami every night. And that was 1,200 baud. And actually that was timed. We actually had to time the bit rate. So we just put it into a little loop. Yeah, it was a primitive stuff before you had chips that did it all for you.
So
So
how
it
did
was-
you reconcile the cash that was in the drawer against the sales that were made during the day? You don't even know who's pushing the keys or who's on the machine all day long, do you?
They put that in the safe. They had a cashier shared, 2 cashiers shared a drawer. And so there was actually a total button for each. I'm not sure how the stores actually reconciled it.
So each cashier had a key for a drawer, or 2 cashiers?
Yes.
Okay.
2 cashiers shared a Mannix machine.
Okay. Thank you. That's
It was a very
part of it.
primitive machine.
Yep. Well, it was a long time ago. A lot of
The display was Nixie tubes. And it was pretty fun. It was a pretty primitive machine. And one of the projects that I was assigned to is we were going to capture timesheets or time cards, because the way they captured time is that the manager would actually call the employees' times down to Miami. And of course, most of the time it went on one of these old tape answering machines, not a digital one. And half the time accounting actually had to call back. So being able to capture that time card information in the store would save, I think, that the equivalent of 3 accounting jobs a year. And the restaurant operations wouldn't fund it because it was roughly equivalent to building 1 store. So it was a different thing. They're doing all that now, of course. But this is back in the early days. And then towards the end of when I started leaving, we converted it to another system, which was a little bit more sophisticated. But the 8 was fun. I mean, it was actually, in Connecticut, we had to do 8K, as I mentioned earlier, because we had 2 different tax routines. Connecticut had both a sales tax and a meals tax. And we had to say which item was sales tax and which item was meals tax. So if you bought a Whopper, that was, of course, meals tax. But if you bought ice cream, for instance, that was sales tax. So that's Connecticut. So these old laws go back a couple hundred years.
Well, Brazil was pretty bad with that too. And one of the things that the Udu people had to do was build the module into Odoo that would actually handle all of the arcane sales stuff that the Brazilian government had. And the company, Camille, contracted that out, got that thing, actually had it pass all the examinations by the government and stuff, and then they gave that code away. They said, hey, everybody needs this. We've got it. We paid for it, but if you're going to be using Odoo, here it is. And now everybody kind of like chips in to keep it up to date and and going. So everybody makes out. It's interesting when you talk about by the way, the PDP-8 was the second computer I ever programmed on. I programmed, when I was back at Drexel, we had a PDP-8 that only had 4K of 12-bit words as core.
Yeah, I didn't mention the 12-bit words. Yeah, my first computer was an IBM 7074 back in 1965. So we go back about the same time.
Yeah. The first one was the IBM 1130 that I programmed on cards. But along the same lines of wiping out jobs, I learned as a co-op student at the Western Electric Company in Baltimore, and we had a floor of about 300 draftsmen who were, doing prints. They would, if you wanted to have something done to the building or a new machine or something like that, they would go to this huge library of print drawers and pull out a piece of vellum that maybe had something like you wanted, and they would duplicate it on a new piece of vellum, and they would make their changes to it and label it and number it and all that type of stuff. And they all these 300 draftsmen were sitting at these big drafting tables with drafting machines and stuff like that. And this is what I was exposed to, right? I took drafting classes in high school where you sat there, you had to buy your T-square and you had to buy your compasses and stuff like that. And after I got into computers and had been out of university for a year or two, I went back to West Electric to visit them. And I went to the drafting department, and the whole floor was absolutely bare. They only had 3 draftsmen left, and they were in this little room with their CAD system. All of the drawings had been scanned in, all of the, stuff was done. And those 3 draftsmen were the only people they needed. 297 draftsmen's jobs were gone.
Yeah. Unintended consequences of computerization. And that happens.
Well, when I was teaching at Hartford State Tech, we had an architectural technology session. So in the 2-year school, you had technologies, and then if you went on the 4-year, you could get an engineering. You went into engineering. So this was this was architecture technology, and most of the kids that took the 2-year course would probably end up being draftspeople for an architectural firm. And the guy who was in charge of our department also saw the writing on the wall, and he opened up a section for his senior students in my Introduction to Data Processing class and made it mandatory for them to take in order to graduate. But he never talked to them about it. So his senior students came in, they were going to be graduating the term after my term, and they just didn't see any use in this course, and they just screwed off. And it came time for the midterm, and out of the 30 kids in the class, 27 of them flunked the midterm. 3 passed with like a C's and D's. And they came to me and they said, hey, what's going on? I says, well, you guys didn't study, and I can't pass you if you didn't study, if you didn't learn the information. So they went to the department head, and the department head came down to see me. He says, what's going on? And I said, hey, look, it's the same book, the same teacher, basically the same tests. My kids get A's and B's, your kids get D's and F's. I says, I can't give them a higher grade for the work they've turned in. So he went back, he said, I got good news and bad news. He says, the bad news is the good news is you may actually pass and you may actually graduate next term. He said, the bad news is you're going to have to work and do the work. So they didn't like that. And they went to the dean of instruction, my boss. And they said, hey, this is unfair. And the dean came down, did the same thing with him. And he tried to tell me, well, you have to teach them. You have to tell them exactly what they need to do to get a D. And I looked at him and says, Dean, I've seen the writing on the wall. These kids don't have a prayer with their skills. The drafting is gone. He says, I don't care. That's actually where we argued enough that I got my nickname Mad Dog, because the argument was too hot for Mad Dogs and Englishmen. It was that time. So there was this one girl. She had gotten straight A's in every course except mine, because she listened to her friends. Hey, this is a slough off course. It's the next to last term. So she didn't study either. And she was so pissed at me that I was going to screw up her grade point average. I says, it isn't me that's screwing it up. It's you. So she was so bad. She went back. She did all of her homeworks. She studied like crazy. And on her final, she got an A. And then I gave her an A for the course. And she came into my office again. She says, how could you give me an A in the course? Because the midterm was 40% of the grade. I flunked it. I says, the best I could do is like a B. I says, I don't test you on what you know halfway through the course. I don't grade you on what you know halfway through the course. And since the final was all inclusive and you got an A, that's what you get for the course. I says, if you had screwed up the final and you got a good mark on the midterm, then I could give you a little bit of help. But this is the way it is. You get an A. So she graduated summa cum laude. I thought I was gone. I was rid of her. But she came back 9 months later. She said, I want to tell you, I sent out 300 resumes. I got 50 first interviews. I got 10 second interviews. And 9 of them turned me down. And then I was at this last office. I was just walking out. I looked over and they had a computer in the office. And I says, oh, you have a computer? And the guy says, yeah, we have a computer, but we can't use it because we don't know how to program it. It uses some language called BASIC. And she says, well, I know how to program BASIC. I took a course. The guy says, would you like a job? And so she came back to tell me that the one professor that she really hated, the one course that she thought was useless, was the one course that got her the job.
Yeah.
So I had one of those. My statistics teacher, Dr. Haas. I could easily have murdered him.
And my uncle, when he was a part-time professor at NYU, he taught statistics. He was telling me he didn't know statistics at all. So he had to actually read up before he taught the lessons and actually learned statistics. He's now retired. He's professor emeritus or something that they call. He still has to teach because he lives in NYU housing.
Yeah, he would teach even if he didn't.
Yeah.
So I I think I got a C in my undergraduate compiler course, and then I got like another C in my graduate compiler course. But I still didn't really understand it, not really good. But then I had to teach it. And as you know, that's the time you really learn something. It's when you have to teach it. Because you can't just bleep over it. You can't just say that's not going to be on the test. And you know that if you try and bleep over it, if you try and slough off of it, that's the thing they're going to ask you about.
Yep.
And so there was many nights I sit there with like 2 or 3 compiler books in front of me. In fact, I think I've got one of them here. There it is, Lewis, Rosencrantz, and Stearns. I have 3 different compiler books, including the dreaded Dragon book, in front of me, taking little pieces of information from each one. And even though I haven't taught compilers for 20 years, I could go up to a whiteboard right now and do a pretty good job of it.
This year's Turing Award winners, AO and Ullman.
All right, so I'm going to tell a little story on those guys. The first books that they wrote, Aho is really all about natural language theory. He's about language theory. And Ullman is about parsing and stuff like that. He's into that. So the first time that they wrote their book, it was 2 separate books. Aho wrote one and Ullman wrote the other. But together, they were like $200 back in 1969. I know. I bought them. I had to buy them. $200 freaking dollars. That's like a month's worth of rent. Okay. So then they realized nobody's going to buy these books, right? They're not going to get the volume out of it. So they jammed it together into the first edition of the Dragon book. And nobody could understand that book. Nobody, right? Even them. They admitted later on, they read the book and they couldn't understand it. So then they had to come out with a second edition of it that they got to be fairly decent. But if you really want to get a good book or a good first book on compiler theory, and granted it's kind of it's not treating a lot of the stuff in standard, would be considered to be standard in compilers these days. This is a really nice book to get. Let's see. Compiler Design Theory by Lewis, Rosencrantz, and Stearns. And one of the really nice things about it is that it does a very simple language, but in the back, it has the language manual for that simple language, and then it has a pseudocode to create the compiler. And so if you take that pseudocode and change it into real code, the compiler will work. And I would have my students do that in their compiler class. One group of students. Another group of students made the mistake of letting me overhear the fact that they hadn't learned Fortran. They were business students and they would normally take COBOL, and Fortran was a second language for them. And they took Fortran from this teacher who was a crappy teacher, and they were laughing one day outside my office saying, haha, they got through the Fortran course without really learning it. And I said, really? Okay, you've got me for compilers. We have a Fortran 4 compiler on our PDP 1170 running Vistas, but Fortran 77 is a new version of Fortran. I want you to write a pre-compiler for Fortran 77 that generates Fortran 4 as the output, and you have to write it in Fortran. Now, for those of you who have never really seen Fortran 4, well, actually, those of you who have seen Fortran 4, you realize it doesn't have very much in the way of character manipulation. there was no real concept of a string in Fortran 4. And so it was a really rotten project for me to give them. And they complained, but at the end of it, they knew Fortran. Some of them still talk to me. Another group of students, I had them write a macro preprocessor for assembly language for the PDP 1170. That was also fun. Okay. I'm going to let you go.
Okay. Well, thanks, John.
Thank you again. Appreciate it.
Yep.
Enjoyed
You-
it.
You might actually see me at the barbecue. I don't know completely yet, but if I, if it seems like, I'll come down and maybe I'll bring some old Linux things for people to see if they would like to have. All right. Take care.
Yeah, you too. Good night.
Bye.